Okay, so the last thing we're going to talk about in this section is what are called absolute, maximum, and minimum. Okay, so let's say we have a graph that goes something like this, okay? And you're like, okay, there's maximums, there's a local max here, and a local max here, and then there's a local min there, right? Okay, and notice that these arrows are continuing downward, indicating that the graph continues to negative infinity and positive infinity. Okay, that the domain is that way. So the domain here is kind of a side note, negative infinity to infinity. Okay, now, and we just said, we pointed out some local extrema. Well, there's a local max here, that's true. And there's also a local max here. We won't worry about the minimum too much. Oops, that's a local max. Okay, but which one's bigger? Okay, so that's what we're talking about. This is the absolute max. So for this function that I have drawn, there is a highest point, and it is right there, right there. That is the highest output we ever get for that function. Therefore, it's called an absolute maximum. Now, if you're wondering about the minimum, well, you do have a local min here, but you can't say it's absolute because, see, these keep continuing down. So there isn't always an absolute maximum or an absolute minimum, but sometimes there is, okay? So like this doesn't have, there's no local, or I'm sorry, no absolute minimum. Oops. So they don't always have them. Okay, now let's have another graph. Not all domains are from negative infinity to infinity for a function, okay? So maybe we have something that starts here, you know, and goes down, and then up, and then down, and then up, and then maybe it stops there. Okay. All right. So you can look at the maximums. Here's a local max. Pretend like I've drawn these well. And then you could say that's the absolute max. That is true. And the other one is a local max. That one is too. They're both local maxes, but the one is an absolute maximum. This is just a local max. It's not the absolute. Okay, now, yeah. Now let's look at minimums. Okay, so I have a local min here. And I have a local min here. Neither one of them are the absolute minimum because the absolute minimum is right here. It's at the end point. That's the lowest point on the whole graph. So that's the absolute minimum. So if your interval is closed, meaning it doesn't go from negative infinity to infinity, you have to consider the end points. You know, is the absolute max at an end point, or is the absolute minimum at an end point? You remember we're looking for output. So how high does it go? How low does it go? All right, well, here we have an example. For the function shown, find the absolute maximum and minimum. Okay, so I'm going from, it looks like about -2.5 to 3. That would be the domain for this function. If anybody asked, hey, what's the domain? Hey, let's do the range too. Good review here. It looks like it's -10 to 16. That's what I would say. Okay. So what's the absolute maximum? It looks like the absolute maximum is here and here, right? Okay, but we just need a value. What's the greatest output we get? 16. That's the greatest output. That's the absolute maximum. So for all our values for this function, the highest output we get is 16. Now, what's the absolute minimum? Well, you can say this is a minimum. It's a local minimum, but it's not the absolute lowest point. This is the absolute lowest point right there, like at -10. Okay? So you just have a couple things to consider when you're doing absolutes, absolute maximum and absolute minimum. Okay? You can only have one, by the way. If it's absolute, like that is the highest point or the highest output, or if it's the absolute minimum, that's the lowest output.